Hello everyone, in this module we are learning the residual analysis and the model building. Okay, every time you run any regression analysis, it's very importantly to do this called the diagnostics, which also means residual analysis, to make sure the assumption we impose on my model are not violated. So some students say, oh, how about the assumption are violated, what should I do? Sometimes you do need to take action to correcting those violation, but sometimes it's totally fine, depends on the purpose of you building this model. So therefore, in this video, we want to learn more about what are the assumptions we are imposed on our regression model, and then so how can we diagnose if those assumptions are violated? If it's violated, what kind of method we can use to correcting the violation, or does that really important for us to correcting those violations? Okay, so in next video, we're going to talk about the model building. So in order to talk about the diagnostic or residual analysis, we need to talk about model assumptions. So for the model we learned, regression model, also called ordinary least square, and then we are talking about why this model is doing really good job to estimating our data, because this OLS estimator, which is all the betas we estimated so far, because we consider unbiased. So that means what we got from the sample data are able to represent in my population. Second, and it has minimum variation between samples. So basically, if we switching samples, so we don't see that value should change that much. And then also, there are compromise when one or more of the model assumptions are violated. Okay, so the validity of the significant test is also impacted if any of the assumptions we're going to talk about next is violated. So if any of the significance is impacted, so that because the estimated standard error might be larger than we are expected, and also not possible to make meaningful inference from the T or F test. So when we are, so that make our significant test invalid. Okay, now let's look at the 5 assumptions I want to call out. So I know in our textbook we mentioned about 6 assumptions. I will explaining why I only emphasize 5 out of 6. Okay, in order to understand the assumption, we have to understanding a very important term, which is called the error term. So the error term basically is the differences between the actual value and the value predicted through the model. So the error term for the population error, basically if we have all the population and we're able to use in the model to predict every of my population observation, so that is called error term. We use this Greek letter called epsilon. Okay, but of course, we are not able to observe the error term, so therefore we want to predict it. So the predicted error term is called the residual. So the residual is calculated by using the actual y value minus the predicted value from based on your model. So given your sample data. So we are using the E. So E is based on your sample data, that is we are able to observe error term. Okay, so using the residual to investigate assumption through the residual plot. So therefore, we're going to look at the residual plot very quickly. So basically, when we're creating residual plot, we are using the residual as my vertical axis, and the horizontal axis will be my predicted y value. Okay, so on Excel, there is something not cool is that they always use if you use their preview, the residual plot, they're using residual versus the x variables, which is not recommended. So in my class, I want you to learn how to creating that residual plot, which is using the residual as my vertical axis and the predicted y as my horizontal axis. Okay, so also the residual plot can also help us detect outliers. So we're gonna learn in the next few slides. And so the reason we can find outliers is because the observation that, remember, within certain standard deviation, meaning within 3 standard deviation, outside the 3 standard deviation, from the mean that will be considered as our outliers. So from the Excel, we are able to derive our standardized residual plot where we are able to very easily detect which observation is my outliers. Okay, so why we need to handle the outlier, because the outlier can affecting the estimation of my betas and also the variance of my betas. So that will impacting my accuracy, my significant test, and also the beta itself. And so, but the question is, why we have outliers? So the answer is, it's not really clear why we have outliers. And so sometimes might be because you didn't record the data accurately. So for instance, if all the data are measured under the thousands, but somehow when you write down the data, you put extra zero in it, so it might become an outlier in your data set, right? And then so if you have outlier, what you're gonna do, so if it's an impactful outlier, you can just delete it, okay? You can delete it or you can correct it. So the way we're correcting the outlier can be you calculating the mean value and using the mean value to replacing your outliers. Okay, so let's see. Now let's look at, this is my residual plot. So my vertical axis is the E, is the residual, and the horizontal axis is the predicted Y. So when I look at this residual plot, I know the data, the model is good. So later, let me explain why based on residual plot, I can know my model is good. Okay, so in next video, we're gonna look at each assumption in details.